In this video, we will see about definition of different type of dimensions and tolerances. We will also see types of direct tolerancing and while specifying decimal inch and metric dimensions, what rules need to be followed. Dimension definition. What is dimension? Dimension is a numerical value or mathematical expression in appropriate units of measure used to define the form, size, orientation, or location of a part or feature. Basic dimension. Basic dimension is theoretically exact dimension. Reference dimension. What is reference dimension? It's a dimension usually without a tolerance that is used for informational purposes only. Tolerance. The total amount a specific dimension is permitted to vary. The tolerance is the difference between the maximum and minimum limits. Geometric tolerance. It is the general term applied to the category of tolerances used to control size, form, profile, orientation, location, and runout. Unilateral tolerance. A tolerance in which variation is permitted in one direction from the specified dimension. Bilateral tolerance. A tolerance in which variation is permitted on both directions from the specified dimension. In the later slides, we will see about unilateral tolerance and bilateral tolerance with examples. Types of direct tolerancing. There are two types of direct tolerancing. One is limit dimensioning and the other one is plus and minus tolerancing. Example dimensions given in the picture for limit dimensioning and plus and minus tolerancing. When using limit dimensioning, the high limit or the largest value is placed above the lower limit. Dimension 22.5, 22.0 is example for this type of dimension. If the tolerance is written on a single line, the lower limit precedes the higher limit separated by a dash. Hole diameter's dimension 7.5 to 7.6 is example for this. With plus and minus dimensioning, the dimension is followed by a plus or minus sign and the required tolerance. When specifying decimal inch dimensions on drawings, we have to keep in mind few rules. 1. A 0 is never placed before the decimal point for values less than 1 inch. The second one is a dimension is specified with the same number of decimal places as its tolerance, even if zeros need to be added to the right end of the decimal point. Things to remember when specifying millimeter dimensions on drawings are: a 0 is placed before the decimal point for values less than 1 millimeter. Zeros are not added to the right of the decimal point when dimensions are a whole number plus some decimal fraction of a millimeter. Few more examples for specifying linear tolerance. When specifying decimal inch tolerances, if a unilateral tolerance is specified and either the plus or the minus limit is 0, its 0 value will have the same number of decimal places as the other limit and the appropriate plus or minus sign. Where bilateral tolerancing is specified, both the dimension and tolerance values have the same number of decimal places. Zeros are added when necessary. Where limit dimensioning and tolerancing is used, both values have the same number of decimal places even if zeros need to be added after the decimal place. These are additional rules for specifying decimal inch tolerances. Next we will see the rules need to be followed while specifying millimeter tolerances. When a unilateral tolerance is specified and either the plus or minus limit is 0, a single 0 is shown and no plus or minus sign is used. This is for specifying millimeter tolerances. Where bilateral tolerancing is specified, both tolerance values have the same number of decimal places. Zeros are added when necessary. Where limit dimensioning and tolerancing is used, both values have the same number of decimal places, even if zeros need to be added after the decimal point. These 3 points are for specifying millimeter tolerances. Where basic inch dimensions are used, the basic dimension values are specified with the same number of decimal places as the associated tolerance as shown in the bottom figure. Where basic metric dimensions are used, the basic dimension values are specified with the practice shown in the top table for millimeter dimensioning. In the bottom table inch tolerances, length basic dimension 3 has been specified with geometric tolerance, that is positional tolerance, dia 0.005. Remember, while specifying inch dimension, if the value is less than 1 inch, 0 should not be placed at the prefix. Since the geometric tolerance has 3 decimal places, the basic dimension, that is length dimension, also has 3 decimal places. Zeros are added at the suffix to match the geometric tolerance. Whereas in millimeter tolerances, length basic dimension 25 has been specified with geometric tolerance position dia 0.15. Here 0 is specified because while specifying millimeter dimension, if the value is less than 1 mm, 0 is placed at the prefix. Here the basic dimension 25 need not to match with the geometric tolerance decimal places. Specifying angular tolerance. When specifying angular tolerances in terms of degrees and decimal fractions of a degree on drawings, as shown in figure, the angle and the plus and minus tolerance values are written with the same number of decimal places. When specifying angular tolerances in terms of degrees and minutes, the angle and the plus and minus tolerance values are written in degrees and minutes, even if the number of degrees is 0.